good afternoon. I'm Jenny Chandela. I'm your host at today's Self-Build Hour. We have the good fortune of being joined today by Iga Panczyna. She's going to be talking to us about passive house design principles. So as a reminder, we have set up the Self-Build Hour as a means for you potential and actual self-builders out there to gather information in the convenience of your own home about various subjects throughout the self-build process. So each month we feature one specific topic, have an invited guest, and then invite you to join us online for a presentation and Q&A with that presenter and expert. For those of you who are joining us for the first time, I'll remind you that this is a recorded episode. So once we finish the recording, we will upload that, and all of the episodes are later available on demand for viewing or reviewing at your convenience. So without further ado, what I should say, apologies, is that you do have the benefit of asking questions if you're here live today. So please use the Q&A function to ask those questions. And at the end of Iga's presentation, I will come back on and we'll have a discussion bringing up those questions that you have asked. So now I would like to welcome Iga to our Self-Build Hour. As I mentioned, she's going to be talking to us about passive house design principles. Iga is a registered architect as well as a passive house certified designer with AC Architects, and she has an extremely creative eye in terms of design. So she combines that with her enthusiasm about low energy design principles. And today she's here to tell us all about what information you need to guide the design in order to get the best performance out of your house and how you would go through that passive house certification process.
Thanks, Jenny, for that lovely introduction.
Yeah, that's great. I can see it well.
Perfect. So just following on Jenny's introduction, just a little bit of background on ACA. I have joined the practice in 2011 when there was only 4 of us. Today in our practice we have 23 people, and that's including structural engineering side. So we do try to provide a comprehensive service to our clients, obviously including the passive house service as well, and structural engineering, as well as principal designer for CDM. With over 500 projects in the UK, we are very enthusiastic to share our knowledge, hence, as Jenny mentioned, the Self-Build Hour. So today I am going to talk to you about the key design principles that will help you to achieve an energy efficient home. So this is just topics that I'm going to be tackling, including a little bit of background on legislation today as well. There has been a lot of movement in that area recently, if you have been observing what's happening in the government. But just to give you a little bit of update and the background to where we are with the legislation today. The UK government has set out the net zero strategy to reduce the climate damaging emissions and decarbonize all sectors of the UK economy, from transport to agriculture. And this strategy set out the policies and proposals to meet that net zero target in England by 2050, including the way we power and heat our homes, which are responsible for around 17% of those national emissions. So some changes are already in place, and what's important, that an uplift in building regulation standards was introduced in England in 2021 and 2023, and Scotland has followed with updates to the technical handbooks in 2023 and beginning of this year, with new homes required to produce around 32% less carbon emissions compared to the previous standard of 2013. So the government plan is also to introduce further regulations and performance criteria from this year, from 2025, through the Future Home Standard, which is aimed to ensure that all new homes built from this year will produce around 75 to 80% less carbon emissions than the homes built to the previous regulations. So it all sounds pretty daunting, but what it means in simple terms for you, if you are planning to build a home, is that you're going to be required to invest a little bit more money in insulation levels and construction method, and potentially install a low carbon heating system, for example, like a heat pump. So this is very simplistic way of obviously communicating what the changes actually are, and I will elaborate on that during our talk. But just to lift it up a little bit, it all sounds quite daunting for those of you who are looking at, you know, your budget and how much money you will be spending on your self-build. So I'm going to talk about some of the benefits of that future home standards and relating that back to the passive house standard and the design principles of it. So obviously, apart from the betterment for the environment and reduced carbon emissions, more tangible thing that you will see if you are building now is that you're going to be reducing your energy bills and running costs over the life of your house, and you will be increasing your property value. So these are the tangible results of the government changes. But my favorite one, and something I really relate to, is that you're actually going to be building a more comfortable and healthy home to live in, because implying those fabric first approach to the design, which I'm going to elaborate in a second for you. Sorry, that skipped too quickly. So for us to be able to talk about the design elements, we need to answer the question of what thermal performance the design your home is trying to achieve. And the space heating demand figure is the commonly used metric to establish this. So just for those of you who are not familiar with the terms, space heating demand is the amount of energy we use to heat or cool the building. So as you can see on the table on the screen, that shows the maximum space heating demand targets for all the different standards available in UK, including for obviously a passive house standard on one spectrum, and on the other side of the spectrum you can see a current building regulation standard in terms of the heating demand figure. So in terms of the heating demand, the building regulations doesn't actually prescribe the maximum figure. This is being estimated by doing the sub-calculations during the process of design of the dwelling. But the estimate on the table on the screen that you can see is roughly where the building regulations would account for at this moment. And obviously that gap between the current building regulations and, for instance, you can see the fabric first target is now narrowing due to the changes that are happening as we speak. So there's still some gap between obviously current building regs and the most onerous passive house standard. And at that point you may be wondering or may have concerns of, you know, if you are going to build today, you know, where in regards of the budgeting for your project. So there is obviously an uplift if you're building to the highest standard, which Passive House Institute estimated to be around 4%. So if you're building to a current building regs and passive house standard, the passive house standard is roughly 4% higher, but that will depend on various factors and it can go higher. So how do we approach a low energy project in economically for you viable way? So I want to give you some tips here. So early decisions on those performance criteria are really important to allow your architect to efficiently design at those early stages. So for instance, if you're designing from the outset with a construction method in mind, this allows you to achieve efficiency within the design and save additional expenses on potentially excessive engineering or material wastage. So if you haven't started the process, it is really important for your architect to be asking that question: what sort of target are you aiming for? What sort of standard are you aiming for? And if you have that construction method in mind, that's really beneficial for your architect to be using that method when they're doing the design for you. So the second tip is use the professionals who specialize in energy efficient design. And I'm not talking here only about architects. Structural engineers have a great impact on design of the structure for the house. They will be potentially specifying the steel supporting structure that can uh, interrupt your insulation levels. So the engineer who is familiar with the passive house principles, with thermal bridging, with the detailing construction is really important on the process, as well as everyone else along the line in terms of the site operatives, etc. So the final one in here is use PHPP tool from the outset. So the PHPP tool is a passive house planning package, which is basically an Excel spreadsheet into which we will input all the data and specifications for your home. For instance, the area of the walls, floors, and roofs, the specifications of windows, the location, the orientation. So that spreadsheet then calculates that energy balance for your future home. So, and what's interesting here that the PHPP design tool is not just for passive houses. So if you are aiming, so say you want to be slightly better than the current building regulations and aiming for a fabric first approach, you can use the PHPP tool to estimate that energy balance. And that is a really powerful tool that we tend to use at the preliminary design stages to guide our clients as to what to invest your money into. So rather than, you know, adding a little bit of insulation here and there, the tool will actually tell us what's, you know, what's the benefit of actually adding that extra 100 mil of insulation. Is it actually worth doing? Or would you be better spending a little bit more money on upgrading your windows? So going into what that fabric first principles are, so we have established that there are thermal performance standards that we could be designing to, and whether you wish to build to the passive house certified level or the fabric first approach, or now building regulation standard, all of these standards will use fabric first approach principles. So and passive house standard is based also on that fabric first approach. So the key to ensuring the transition to those low carbon heating is cost effective for you is to adopt that fabric first approach. And what this means is that we're going to be focusing on all the passive elements of the build, like improvements to your floor, wall and windows, and not necessarily technologies. Sorry for that, I skipped too quickly. So there we are. So that's the basic fabric first approach elements. So what it means is that that passive house standards translate in that simplicity. So you will be building a house that has an excellent thermal performance and air tightness, a house that makes use of the site orientation and that free solar gain, and that includes a healthy ventilation strategy. So obviously orientation will be important here with a long elevation facing the south. And the second kind of graph, you can see a solar gain and passive shading. So why we're talking about passive shading, I will elaborate on that further down on separate slides. But obviously what we want the free solar energy during winter and during summer. We want to prevent overheating. So hence the passive solar shading. So obviously we talked about high insulation levels and potentially a thermal bridge-free construction, and the next one down is the internal layout. So when we do design the house, what we want to do, we want the orientation of the main daytime living accommodation, like kitchen, dining, bedrooms, to be located towards the south, and the rest of accommodation, like a plant rooms, utility, hall spaces, towards the north. Another element of the fabric first approach, which is also a key, so we talked about obviously insulation envelope. This is the windows. So obviously a triple glazing, typically would be triple glazing units for the passive house and low energy home. And the last one is the natural ventilation. So using this fabric first approach with these simple key elements will allow you to achieve a low energy home. So I just want to talk to you a little bit about site consideration. So that this may be the first thing that you will need to consider, and in terms of what your plot and what impact the plot features will have on the design of the low energy home. So this will be quite valid to the people who don't have a plot and who are looking to purchase the plot, or for those of you who identify the plot but are not quite sure, where to start. You might find the next couple of slides quite useful. So when we look at the plot, what to watch out for? Okay, so when we are looking at the site, and this is something typically that we would do as architects. So if you come to us, we can make that assessment. And in ACA, we tend to do it free of charge, a little desktop analysis for you before you purchase the site to make sure, you can build there. The dwelling that you dream of. So what you want to do when you're looking at the site, you want to determine the position of the sun throughout the year, which will provide you with a spectrum for that solar gain and guide the house orientation. You also want to establish temperature ranges, both seasonal and daily. You want to identify the direction of prevailing wind, which may determine where you're going to locate your openable windows or potential front doors or any external sitting areas. Excuse me. So you want to also determine the seasonal characteristics like cold northerly winds in winter, and analyze any impact of any neighboring buildings that can optimize or degrade the performance of the building. So as you can see, the little kind of picture on the screen, this is the plot more sort of in the countryside with a existing building to the north marked in red. So that building is in quite a distance, so potentially doesn't have that much impact. But if your plot, for instance, is in more sort of urban situation, when you are sandwiched between two other plots with existing buildings, and the building to the left is actually on your south side, that may have quite a big impact on that solar gain that you would be hoping to basically employ in the design of your building. So obviously it's not the end of the road for you. You can, architect with the right skills can design some features like higher level roof lights and so on to gain that free solar gain within the passive design for your home. So the last one here is obviously the topography of the site that can also impact the performance of your building, and any kind of trees and shape and orientation of the site. So if we then look out slightly, if we zoom out from this picture and we look at the kind of wider context consideration, that can also impact the design for the house and specification for particular windows or finishing materials as well. Whether the site is located, say, near the valleys or mountains and sea, all of that creates a specific microclimate that can impact on how the building will perform. So the key thing here is you don't potentially need to worry too much about analyzing all of that. Your architect would be helping you on this journey. So contact your architect if you do locate the site and speak to them before you make an offer or make an offer subject to. Okay. So I want to talk to you a little bit about home orientation. So once you located that site, we're happy with it, we're going to be looking at the site orientation, at the building orientation on the plot. So when we start the design process, we will be looking at any kind of site features that we want to use within a design. So that could be your short or long distance views. So, the orientation of windows could be directed towards them as well. And we would be looking to create the desired house layout to maximize that site potential and obviously including all your requirements. So the south orientation is obviously what we said before, one of the principles of the fabric first approach. It is the easiest site for a maximum solar gain and the methods of shading. And again, why am I talking here about shading? Obviously, if you have a south-oriented building and you are designing a contemporary house, potentially with an area of the windows that is over 25 to 30% on the south wall, your building, your home will overheat. So at that point, we need to start allowing for a form of passive shading, and that could be canopies, extended roof overhangs, balconies. We can use all of those passive elements to provide that solar shading so that there is a control of that heat coming into your home. So ideally, obviously, the longest house elevation with large windows would be orientated within 30 degrees of south along east-west axis to gain that maximal solar radiation. And this is the reason why we said before, this is the kind of elevation that are most frequently used for the areas of kitchen and a daytime accommodation. If this is not possible, as it can happen, obviously not all the plots will have that ideal scenario that you can put the longest elevation on the south. You can give the consideration to the east and west aspects, which are slightly more challenging to control overheating due to the sun positioning on the sky, particularly on the west that features late afternoon light. So other aspects you can use when we talk about passive shading, you can use the wall thickness to create a deep reveal. So you're placing your window closer to the internal walls, and that helps in controlling that heat coming in. And we also said already that you can incorporate a canopy or roof overhang to the design from the start and before applying for planning permission. So again, talking about that shading and passive shading. So when we look in the site and what features are within the site, you can actually optimize the solar gain in the winter by making sure that the south-facing windows are not overshadowed for the best part of the day. And you can also use trees and planting to aid those optimal shading scenario, as well as obviously, shelter from the cold winds. So deciduous trees are often used if they are available on the plot to optimize shading in the summer, whilst when the leaves are done, the sun can still penetrate into the building during the winter months at lower winter angles. Again, we can use evergreen trees more sort of on the northern side if there is a northerly wind present on the plot. And I've got a little summary here on the shading and orientation. So obviously overhangs and shadings, as we said, are important devices in the passive house because they can help in reducing that overheating during the summer months and summer season. But it's very important that the shading devices are properly sized so that they can let that sun during the winter months where we do need that extra solar gain and when it is a more desirable. So on the south facade, as a rule of thumb, if you want to size the overhang or a fixing shading depth, would be to apply a 60-degree angle to the lower edge of the glazing, and that will give you that depth of that overhang. That is the optimized scenario. So obviously we said also that due to the angle of the sun on the east and west, this will not work, and other means of shading will need consideration at that point. So you can opt to put retractable shading devices on the outside of your window. However, if your predominant views are towards east or west, you probably don't want to, you won't be using that devices. So the kind of last result that we tend to go to is to upgrade the window G value. And the G value is the factor that can help with managing that overheating, which has an impact on, but it can have an impact on cost. So if you ask the supplier to provide your window with a lower G values, it can have impact on costing and aesthetic, and generally is not an economic solution and would be the last recommended results. So because of shading devices can have that big impact on the building appearance, as well as reducing the cooling demand, what we tend to do and what we tend to encourage is to consider and evaluate this aspect at early stages of the design process. And that will help you to be more cost effective with the design, but also it will help you to integrate those elements into architecture of the house and the overall aesthetic. So you don't want to end up of not having considered that, and then further down the line you find out that there's an overheating risks, and then you have to add something into the buildings. And also you may be in a scenario that you're going to have to go back to planning department for retrospective planning permission. So again, going back to the basics, if you consider that from the start at the design stage, this should save you money and time in the long run. And the way we do it, again, I would encourage the use of PHPP tool, so Passive House Planning Package tool, that will estimate the overheating risks for your home. So there are other ways of dealing with overheating. So obviously you could be more sort of conservative with a number of windows on east and west elevations, because they are quite difficult to shade compared to the south side. Another point is north facade can be out of shading as it receives very little direct solar radiation. And the one thing to bear in mind also is that the interior shading devices such as Venetian blinds or vertical louvers can be used for solar gain. However, they have a very limited ability to stop that solar gain, so the building will still overheat with those. So another aspect of fabric first approach and the design of the passive homes that we are looking at is a form factor. And a form factor is a measure of how compact or spread out the design is. And it is effectively a ratio of all the external surfaces areas to the usable floor area. So the higher the factor, the less the efficient the design is, and the most costly it will be to build it to the passive house standard. So as a rule of thumb, the form factor will equal around 100 millimeters of insulation. So as you can see, if your building is more spread out, as you can see in the bottom of the screen, then that costs will rise and your wall thickness will also increase. So if you are building in, for instance, conservation area and you're limited with your footprint, that may have an effect on your internal space that you're going to be left with. So when we're designing a passive house, we want to design to minimize the building surface to volume area. So, but that not necessarily means that you have to compromise on the building form. So that's another kind of misconception that, the passive homes are only square boxes. You can build any form of the house, any aesthetic, any form to the passive house standards. It just means that if the form is more elaborate, as you can see here on the screen, on the left-hand side, we have a design with a form factor 2.7, which features almost like two dwellings linked together. So the areas of walls and roofs, it's much bigger than, for example, the house to the right-hand side with a form factor 1.6. And above those images, you can see the impact that form factor will have on the insulation levels you will have to construct the home to achieve the passive house standard. So if your budget is your main constraint, the lower the form factor and more compact design makes it easier and cheaper to achieve the passive house, the fabric first standard, with the walls, roof and floors that can be a little thinner. And the next one, the next aspect, which is quite important as well, is the windows. So the glazed surfaces play an important role in the passive house because they serve as solar collectors, bringing the light and the heat, whilst also providing a natural ventilation. So locating the majority of glazed surfaces on the south facade, as we already said, helps in achieving the maximal solar gains. While reducing the ones on the northern facade, that will help the use of the insulation within your construction build-up against the winter cold. So the type of glazing and frame is the key feature when we consider the specification and insulation properties of the windows. And passive house will usually feature thermally broken triple glaze units with a maximum U value of 1 and airtight installation. So one thing to bear in mind here again is even though you may be specifying the best product, the best triple glazing product on the market, the large areas of glazing of high thermal performance at best will be between 4 to 6 times worse than the performance of your wall. So we all love obviously designing large areas of glazing, and that connection, the daylight coming in, and obviously connection to the outside space. But just to give you that kind of picture of what that does in terms of the thermal performance, that if you come to the architect and say, well, I want all of this wall to be glass. Yes, of course we can do this, but bear in mind, you're going to be losing a lot of energy through that wall, much more than through your through that window, much more than through your wall. So when you're creating your project brief, I would be taking that into consideration in terms of the kind of areas of glazing you want to specify. So I also included on the slide an extract from the PHPP planning package, which is an energy balance. And on the left-hand side, you've got shown losses, and on the right side, there are gains. And the yellow area is the areas for the windows for a design shown to the left. So as you can see, there's actually more losses through the windows for that design that are gains. So with this specific design, you can see that there's a lot of windows on the elevation, but this is the east elevation of the dwelling. Hence, there's more losses because there's only a small window when we can get more solar gain during the day. And the final kind of note on the windows here is that the full high glazing is a nice feature. Again, we love designing full high windows, but this can cause overheating risk and heat loss with no actual additional benefit to daylight. So anything below 700 mil to the finished floor level, it won't gain you an additional daylight into the room. So just to summarize the windows, so instead, what you can be considering, you could be more conservative with areas of glazing. And if there is over 25% of glazing on the south facade, you would want to accommodate that external canopy or extended roof shading or brise soleil to limit that summer overheating. So what can you do on the east and west? Obviously, you can extend, you can use your reveals to place the window deeper into the building. You can extend the walls to help you managing, depending on the angles. But you can also employ features like a picture frame view to picture frame the views from those windows and in those key areas. So, and going back again to that southerly position, you want to focus on the southerly aspect for any kind of larger units. So I've got a few slides here regarding the construction methods. So just to pre-warn you, I won't be talking about what construction method you should be using for a passive house, because that would be entirely separate talk. But what I wanted to talk to you is that the building design to the passive house standard obviously require well-insulated, airtight building envelope with a ventilation system that can recover the heat from the exhaust air. And when we consider insulation levels, what we do, we check the U values of the construction buildup, which measure the ease that the heat passes through the building assembly. And the lower the U value, the better the insulation thermal properties. So again, on the table on the left, you can see a varied standards that shows you the U values of the components as well as airtightness backstops. So when considering the construction method, apart from specifying the high level of insulation and the buildup of the construction that will reduce the thermal bridges, you want to make sure that your building will be airtight to reduce any kind of air leakage and the heat loss through any kind of gaps and cracks within the fabric of the building. So it's quite surprising how much heat escapes through little gaps within that passive house standard. That's why passive house build. That's why you can see that difference in terms of the numbers of the air permeability of the air changes with the passive house being a 0.6, where the current building regs are showing it at 5. So as you will be limiting that air movement, you will then require to install mechanical heat recovery ventilation system in order to maintain that air quality for your internal comfort. And this will also aid to recover the heat from your heating system. So these are basic performance criteria where, when we are choosing the construction method, that are helpful in you choosing that. So one thing to say here in terms of the construction method suitable for a passive house, I guess, that you can actually build a passive house for any construction method. And there are other aspects of that consideration that are worth mentioning here, but obviously somebody could be looking at block and beam construction because there's availability of contractors who do that in your area, and of course you can do that. It's slightly more challenging when it comes to the detailing, so there are modern methods of construction that have been specifically developed to deal with those aspects of fabric first approach. So some are naturally airtight, obviously some have continuous insulation internally, and it's much easier to avoid any errors on site while building from those methods, particularly if they are factory made. So there are other considerations that you can see on the screen on your slide that you need to ask yourself those questions, and that will help you in that construction choice as well. So just a quick summary of how to choose the construction method. So you want to do your research and decide which construction method best suits your requirements, including budget, speed, and thermal performance. And then what we generally advise our clients, you select the construction method and then you go out to the 3 suppliers of that construction method and get comparative quotes. Look at the factory, speak to the manufacturers, build the relationships with them, because that will allow you to negotiate the best price. And just a quick summary, what I talked to you today. So basically use the principle, if you're wanting to design of low energy home, use the principle of the passive house and engage with professionals who are familiar with the low energy design that will be able to provide you some savings and obviously share the knowledge with you. And early decisions on the design performance criteria are really vital to allow efficient design in early stages and save you money. And the key from me is really use the PHPP tool from the outset, because that will provide you again with the choices of where to invest your money to as well, apart from the obviously the results that will show the heating demand figure, the overheating figure, and that energy balance of the future home you're going to be paying for. And since you've done all of this, since you invest all your money already in those upgraded insulation levels and windows, why not consider certification? So the certification then will give you an extra comfort, because it's a quality assurance check that there is a certifier involved. So you'll have your passive house consultant that will carry out the passive house service throughout the architectural stages of the projects, and then the certifier will be reviewing all of that information, including the kind of checks on site. So I've got a last slide here for you. So if you would like to take a picture of the code here, I know we're going to be sharing this, but if you want to arrange a consultation with myself, if you scan the code, this will give you an access to book a consultation, also to download our ebook, which is a self-built ebook. So it's not just Passive House, it's the ebook is quite a developed document that talk about the whole process from start to end. Yes, and that would be like everything from me just now. So I'm just going to stop sharing, Jenny.
Perfect. No, that was really, really helpful. Thank you, Iga. You talked a lot about things that have been reinforced over and over on a lot of these chats that we've had on Self Build Hour about thinking about, that how low energy you want to be from a very early start, what construction methods could you be considering, and a lot of very detailed information about sort of the legislation that's coming forward that actually, if you're designing to these principles, you're future-proofing your project from those changes. Where do you see, I know there's a lot of talk about sort of Scotland going to Passive House within their building regs in terms of criteria. England is often quite, sort of follows behind what Scotland does in terms of building regs. Where do you see this going? Do you think Passive House is going to get more strict, or do you think Passive House stays where it is as a certification process and in terms of guidance?
I think there's a certainly push towards the Passive House. So what we are observing just now in terms of the legislation, a few years ago, we were designing to a fabric first targets. And as you know, AC architects, we have been doing that since 2009, really, since the practice has opened. But what happened is, because of the changes to the legislation and building regs, the building regs are actually thereabout where, what we used to design the fabric first targets are. And the push towards the Passive House, I guess, standard, whether it's going to overtake at some point. I mean, in Scotland, there's changes already. So unfortunately, they've not adopted the PHPP planning package to be used to basically go through the building warrant process, but there is already a conversation, and that there's already changes in place that there's an equivalent to that Passive House standard that is being implemented. So that's already happening. So I think it's a really good thing. I know I'm a little bit biased because obviously I'm a Passive House consultant, but I am Passive House consultant for a reason, because I really believe that this is the way to be building. And in a way, I'm a little bit frustrated that, the process of the government going to that point is so slow. But that's on the side. It does cost more to do a Passive House, but it's not a huge difference. It's just not. And if you're thinking about obviously doing a low energy, you're already doing it. So you're already investing slightly, but a bit more money into those levels of, insulation, what we talked about, triple glazing windows. And a Passive House standard, it's more sort of a holistic approach. So it's not, as we were saying, it's not, I'm going to just throw a little bit of insulation here, a little bit extra there. It doesn't work like that. It's a look about throughout the whole aspects of the building physics, how the building works, and what's the impact of that on the actual internal environment that we're creating. So it is a holistic way of designing of healthy homes. So I definitely, if it was up to me, that would have been done quite a few years ago in terms of the legislation. But I think we are, the good things is that we are getting there in terms of the government doings.
Yeah, exactly. They're pushing in the right direction in terms of where we all want our homes to be, actually, but most of the ones being built currently under either the past building regs or even the newest ones still aren't quite there in terms of what we all would like to have and should have on the housing market. And relative to costs, I think you said 4%. I assume that has to do with construction cost uplift. When it comes to the PHPP calculations and then the certification, there's going to be additional professional fees within that as well. Is there a rule of thumb or an amount that someone might be able to expect, even if it's a ballpark?
So yes, so there's an additional cost for obviously the time that will take us to run the design through the PHPP software, and then there's a certifier involved, and we tend to be involved throughout the whole process. So we tend to be involved on the big initial stages. So we do the PHPP as a preliminary kind of calculations on the design that we can then guide the design and basically say, okay, well, if we do, small changes here and there, we actually are, the building actually going to be much more efficient. And then obviously throughout technical stages, we provide assistance to technical teams throughout that in terms of the detailing and specification, and to our clients as well. As we were saying, if you use the PHPP tool, we've got a tangible numbers to be working with rather than just, I'm just going to have a guess here. I'm just going to add that 50 million installation and hope for the best. It doesn't work like that. And the PHPP tool allows us to assess this and actually, saves you money in the long run. So yes, it is an additional cost, and I would say it's roughly potentially like 2% of your construction cost. 2% of your professional fees. So it's not construction costs. That would be way too much. So if you think about it, if your standard architectural fees, according to RIBA guidance, would be between 8 to 10%, your structural engineer is going to be 1.5 to 2%, and passive house consultancy will be another 2%, 1.5 to 2%. It all depends on the complexity of the design. But what we tend to do a preliminary costing first. So you're not committing, because we can guarantee that the particular design will actually meet the passive house standard criteria. So what we tend to do, we tend to run a preliminary PHPP calculations first, and we stage the payments. So you're only looking at the preliminary PHPP if you want to see if the building even gonna, pass the standard. And then if it does, then there's a full PHPP calculations that we cost for. And that's usually happens at the technical stages as well to guide the team.
Okay, so that leads to another question that I often get asked at the center when people, they'll come to the passive house workshop or a low energy workshop and start learning a little bit more, but they've passed the hurdle of planning, and they sort of, a lot of people, once they get through that point, don't want to go back. But the idea of passive house was something maybe they didn't know about when they were starting, or didn't understand that their early design decisions would influence it. So it sounds like someone who's in that scenario, who has planning for a project, really wants to move forward with the project, but is interested in passive house, could potentially get an initial PHPP completed to find out where they are in terms of, possibility, I guess, of pursuing certification.
No, absolutely. We talk obviously about, generic scenario if you're just starting the process, but there's there is an opportunity for you, I guess, if you do have a planning permission, and if you haven't, went through the PHPP process at that point, it's absolutely fine to use the PHPP at that point, because it's actually going to help you to make decisions on the construction method potentially. And this is the bit that a lot of clients come in and they are unsure where to progress from here. They want to go low energy. They go to the home building and renovating shows. There's so many construction methods that they just confuse as to where to go, who to speak to, and obviously if they speak to different suppliers, different manufacturers, there will be selling the materials that they do. So the PHPP does help in, making those decisions as well. So if you are unsure, or as you say, if you are you want to certify, we definitely can check the current design and provide our guidance as to specifications, potential improvements. If you do have a planning, you don't want to go back to planning, we can also work with that. So we always have a conversation with potential clients as to what their requirements are, and then take a balanced view as to how to progress. And remember, Passive House Standard actually have another option that has been introduced not that long ago. So it's a most honor standard, as we know, but because some of the houses didn't quite meet the Passive House standard, the Passive House Institute came out with another less onerous standard, which is Passive House Institute Low Energy Standard. So actually, if your design is fairly spread out and it's quite hard to achieve that exact Passive House standard, you can still certify. It's just going to have a different name. So it's going to be Passive House Institute Low Energy Building rather than Passive House, but the process is exactly the same. So the quality assurance is exactly the same.
Well, and that's a really good point, because with planning requirements in certain area, people are going to be building in certain areas that have really stringent requirements in terms of the form, the orientation, the amount of glazing, whether they can have overhangs. And some of those design decisions will really have an impact on the efficiency of the form and the ability to pursue certification. So even if it was something that they had thought about from the very early stages, it might just be that in that particular area, because of the planning requirements, it would be very difficult or potentially even not possible to have the standard Passive House certification. So Passive House Low Energy could be a really good way of sort of keeping everyone focused and having something that they have to achieve, a target that they have all committed to achieving.
No, definitely, and that's the thing we were talking on in the beginning of my talk, that engaging obviously professionals who are familiar with it, but the site operatives, they're gonna have a key role as well, because they're gonna be doing the airtightness of your building, and if there's a tiny wee gap within that airtight layer, your air test will fail. So it's really crucial for for the workmanship to be there as well. And going through the certification process is another layer of those checks that everyone will have to do. So you basically, you will need to, have photographs from all the kind of products that are being used on site, have proper checks on those sites. So, if that's a worry for you as well, that the workmanship is not going to be quite there, again, going Passive House standard certification route will alleviate those risks as well.
Fantastic. Well, I think that was really, really helpful. Unless anyone else has any questions, I think I will close with sort of the top takeaways that I put together during the presentation that you were giving, Iga. But I think you've really sort of given a really broad overview of both the technical and the practical sides of Passive House design principles. So you finished up by talking about sort of the Passive House sort of certification and considerations with that. I've jotted down just a few notes about Passive House design principles and some of the things that people might want to consider. So the top takeaways for me were: a Passive House is not only a low energy home, but it's also a home that provides a healthier indoor environment. Secondly, early design decisions have a significant impact on the performance of your build. The characteristics of your site will also have an influence on your proposed design solution. Consider laying out your home by thinking about heat loss and heat gain relative to all of those site characteristics, those wider site characteristics. And key considerations for your envelope are windows, passive shading, and form factor. So
you've noted quite a lot. Excuse me. Excuse me. Yes, that's a good summary. Thanks, Jenny.
You're very welcome. Thank you very much. I'll just close by talking about what's coming up next. And so today we had Iga joining us, and next week we will be joined by Mark Miller, who many of you will know from television programs, including DIY SOS. So he's joining us to talk about what are the things as a self-builder that you really can do yourself. So join us next month, 13th of March, same time, 1 p.m. For the Self-Build Hour, where we'll be joined by Mark. If you're enjoying the format of these self-build hours, we do also do live in-person seminars at the NSBRC, as well as in our office in Fife. The next one coming up in Swindon at the NSBRC is the 12th of April. You can get more information when we send out our follow-up email with our top takeaways on that, as well as going to our website. So I look forward to seeing you all next month. Thank you very much for joining us.